Matrices. In life, we encounter activities that require organization of data in a tabular form. For example, a salesperson sold cakes, sodas, and loaves of bread in 3 days of a week and reduced the information as shown below. Introduction. There are various situations in life that may require formation of patterns to ease computation. In this lesson, we shall look at how the formation of patterns is linked to the knowledge of matrices. Definition. A matrix is a square or rectangular arrangement of numbers, letters, or symbols. For example, matrix A, B, C, D is a square matrix. Matrix E, F, G, H, I, J is a rectangular matrix. Each entry in the matrix is known as an element. An element in a matrix is described by its position in terms of the row and column in which it is located. The following is a matrix which can be used to show the location of various elements. Matrix 5, 6, 7, 3, 8, 10, 4, 11, 13. 5 is located in the first row and first column. 6 is located in the first row and second column. The locations of other elements can be identified in a similar way. Order of a matrix. A matrix is described by its order, that is, the number of rows and the number of columns it has. If the order of a matrix is written as 2 multiplied by 3, it is read as a 2 by 3 matrix. This means it has 2 rows and 3 columns. Example 1. The order of the matrix A given below is 4 by 3, meaning it has 4 rows and 3 columns. A is equal to matrix 2, 3, 4, 1, 2, 3, 4, 5, 6, 0, 8, 7. Is of example 2. The order of the matrix B given below is 3 by 2, meaning it has 3 rows and 2 columns. Example 3. Matrix 2, 0, 1, 5. This is a 1 by 4 matrix since it has 1 row and 4 columns. Note example 5. Matrix 3, 5, 4, 7. This is a 2 by 2 matrix. It has 2 rows and 2 columns. Square matrix. Among the following matrices, one can identify examples of square matrices. 1. Matrix 1, 2, 3, 4. 2. Matrix 1, 5, 7, 9, 2, 3. 3. Matrix 2, 3, 4, 5, 5, 7, 1, 8, 4, 3, 2, 1. Compatibility in addition of matrices. Matrices are compatible for addition or subtraction if they are of the same order. Example: matrix A is equal to matrix 2, 3, 4, 5, 7, 1, 4, 3, 2 of order 3 by 3. Is compatible with matrix B is equal to matrix 5, 2, 1, 3, 7, 6, negative 1, 0, negative 2 of order 3 by 3. Adding matrices A and B, you obtain the following result. Matrix 2, 3, 4, 5, 7, 1, 4, 3, 2 plus matrix 5, 2, 1, 3, 7, 6, negative 1, 0, negative 2 is equal to matrix 7, 5, 5, 8, 14, 7, 3, 3, 0. Similarly, matrices A and B can be subtracted to give the following result. Matrix 2, 3, 4, 5, 7, 1, 4, 3, 2 minus matrix 5, 2, 1, 3, 7, 6, negative 1, 0, negative 2 is equal to matrix negative 3, 1, 3, 2, 0, negative 5, 5, 3, 4. For any two given matrices to be compatible in addition, they must be of the same order. On compatibility, introduce the idea of scalars. Given the matrix A is equal to matrix 2, 3, 4, 5, 7, 1, 4, 3, 2. Find A plus A is equal to matrix 2, 3, 4, 5, 7, 1, 4, 3, 2 plus matrix 2, 3, 4, 5, 7, 1, 4, 3, 2. Therefore, 2A is equal to matrix 4, 6, 8, 10, 14, 2, 8, 6, 4. Multiplication of matrices. The following table shows various types of biscuits, their quantities, and corresponding prices. We can work out the following total price as follows. Into brackets, 200 multiplied by 40 plus into brackets, 150 multiplied by 65 plus into brackets, 300 multiplied by 50 plus into brackets, 250 multiplied by 75 is equal to 43,500 Kenya shillings. We can find the total cost of the biscuits by multiplying the above matrices. This is done by writing the first matrix as a row matrix and the second as a column matrix, and then finding the product of the matrices as follows.